This is Anthony Precella working with my face-to-face Math 1324 class today, working on the final exam review sheet for my face-to-face class. So, problem number 1. First few problems begin with our probability that we were doing last period. So, let's see. Starting here with number 1. Find the odds in favor of the indicated event. So let's see, what do we have here? We have, what are the odds in favor of randomly drawing an even number from the cards pictured below? So these are tiles here, or cards, numbered 1 through 5. Well, to calculate odds, you count how many ways can you draw an even number. Well, there's 2 ways you could draw an even number. To what? How many ways can you not draw an even number? 3. So 2 to 3 are the odds there. Not a lot of work to it. There's some problems we've done this semester where you have to, a lot of work to get to the answer. That's not one of them. Okay? Let's see, number 2 says, okay, it's still find the odds. Find the odds in favor of rolling a number less than 3 with a fair die. Always those fair die, no loaded dice here. Okay, so we rolled a number less than, we're rolling a die, let's say. Let's write out all the possibilities. It would be 1 through 6. This is called the sample space, the list of all possible outcomes. So, what are the odds in favor of rolling a number less than 3? Well, how many numbers less than 3 are there? 2. So there are 2 numbers less than 3. How many numbers are not less than 3? 4. But wait a minute. We reduce odds the same way we reduce fractions. What can I divide both of those numbers by? A 2. So if I divide both of those by 2, we'd have what? 1 to 2. So that is C here. Oh, I forgot to fill in this one over here. Number 1, what's the answer there? It is A. Any questions there? Okay. Just anytime you want, just call out, speak. If you have any questions. Let's see. Now, the next one, convert the odds to a probability. And that was something we were discussing the last class period. The connection between odds and probability. Like on problem number 1, the odds in favor of rolling an even number were 2 to 3, but that wouldn't be the probability. If it had asked what's the probability, you'd say 2 over 5, 2 out of 5. The way the odds A to B is equivalent to the probability A over, and what's this bottom number? A plus B. So the bottom number is the sum of these 2 numbers right here. So let's see. Number 3, the odds in favor are 1 to 2,300,000. So that's the odds in favor of winning some lottery. What's the corresponding probability? Well, it would be 1 over 2,300,000. What am I about to write? A 1. Okay? These two, the sum of these 2 numbers should give you the bottom number in the probability. So let's see, which one is that? Is that B? Now, number 4 deals with expected value, and that's another word for it, or another phrase for expected value is the weighted average. It looks like all the possible outcomes here are the numbers 24, 26, 28, 30, and 32. And probability of getting a 24 is 14%. Probability of getting a 26 is 12%, and so forth. If all of these were equally likely, then the middle number there would be the average. But they're not equally likely. In fact, 28 is the most likely number. So how do we calculate that that expected value? Do y'all remember what we do? You take this times that, the number times the probability plus 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 the number times the probability. Hey, do I have a calculator here? It's in the box. Oh, behind the box. Okay. I'm going to use my calculator. You won't really be able to see it because of the glare, but this way at least I can get an answer. Let me see. I am punching in. Oh, let's see. Okay. 24 times 0.14 plus 26 times 0.12 plus 28 times 0.46 plus 30 times 0.26 plus 32 times 0.08. 29.72, is that what you said, Brenda? That's right. Okay. Oh, again, it's a bad glare using a calculator here. Hey, I should use my phone. I think it works better then, but yeah. So this is the new stuff. The new stuff being it wasn't on a previous test. This was that last assignment we were working on the other day. Gentle introduction to probability. Okay, so number 15. A card is selected from a deck of cards. One card is selected from a deck of cards. Find the probability of selecting a red card or a queen. I don't think I brought my picture of the deck of cards, so y'all just sort of imagine what a deck of cards looks like. I know I used to have a little printout of it to show, but oh yeah, okay, thanks.
I had to paint it out.
Oh, okay. Oh, look at this. Okay, so here's my deck of cards, and I forgot what the problem said. Let's see, what do we have? Find the probability of selecting a red card or a queen. Now, the significant thing is don't count anything twice. There are 26 red cards, 2 of which are queens. And there's 2 black queens. So how many red or queens are there? Well, there's 26 red plus 2 black queens. I'm picking on the black queens because we've already counted the red queens. Out of how many cards? Well, a standard deck of cards has 52 in it. So we have, what is that, 28 over 52? I bet we can reduce that. What could we divide both of those numbers by? Maybe we divide by 4? Would that give 7 over 13? 7 over 13? Okay, C. There you go. Any questions on that? This is the review sheet for the final. I'm just sort of working through it. Okay. Ideally, we'd get through number 18 today, and I've already done 19 through 28, but I don't think we'll get that much done. Number 6 and 7, so that ends the probability part. Number 6 and 7 go back to that stuff that we did at the very beginning of the semester, working with logarithms, and this is some of the stuff that definitely follows you through if you're taking the second part of the course, Math 1325. Math 1325 is a calculus course for business. But the operative word there is calculus. There's not a lot of the stuff that we did or we do this semester here that carries over there. What you've got to be able to do for that calculus course is know your algebra. Know these properties of logarithms, for instance. So, up to number 6, it says use properties of logarithms to expand these. Well, one thing you've got to be able to do is rewrite radicals with fractional exponents. A square root is the same thing as a 1/2 exponent. A cube root is a 1/3 exponent. A fourth root is a 1/4 exponent. A fifth root, a 1/5 exponent, dot, dot, dot. I don't think I need to go on any further than that. To expand logarithms, if you have a radical, you've got to first write that as a fractional exponent. So I'm going to write this as log base 8 of 17 to the 1/5 power. That's a 1/5 there. It might be hard to read. That's the fifth root. A fifth root is a 1/5 over y squared x. And now I'm about to expand, which is using the properties of logarithms. The power rule, the quotient rule, the product rule. And the way we do these is we say, okay, you separate logarithms at multiplication and division. So here is division, right there, multiplication. Whose phone is that going off? So, I'm joking. Let's see. It's been a while since we've done this. Let me cut this volume off on my phone. That's the problem with these little videos. Every now and then, things happen. I remember once there was a fire alarm when I was making one of these, and I forgot to cut it off, and so it kept recording. We evacuated the building and so forth, and then once I finally saw it, I was like, oh darn. So I wound up redoing it to an empty classroom later. Okay, so to expand these, you write the exponent, then log base 8 of 17. The stuff that's on top has a plus in front of it. The stuff that's on the bottom has a minus. So this this y squared, we'd write it as a minus because it's on the bottom, 2 log base 8 of y. And then for the x, that's another minus because it's on the bottom, log base 8 of x. There wasn't an exponent on the x, so I didn't put a number in front of the letter L. So now we got to look at these answer choices closely because they sure all start blending together. It looks like A and B look the same. How do they differ? Yeah, plus there, and it should only be it should be a minus. So this one's A. Maybe it would be a good idea for me just to make sure y'all see that pattern before we do the next one. I'm going to just sort of review how to expand logarithms with an example. How to expand logarithms. And this is just going to be an example. I'll make up one. Let's say we have log base 2 of a to the 3rd, w to the 4th, x, just x, all over 5 y squared, and one more letter, c to the 7th. How do we expand that? Well, Well, first of all, how many times am I going to have to write log base 2? How many ways will I separate it? You separate it at multiplication and division. The stuff that's on the bottom is going to have a minus sign in it. So how many minus signs will there be? There's going to be one for the 5, the y squared, and the c to the 7th. And the pattern. You start off by writing the exponent, 3. Then you write log base 2 of a. Now we move to the w. It's going to be a plus. Do y'all hear Brenda? Plus 4 log base 2 of w, and then plus, there's not an exponent on the x, so if you want to write a 1, but I have a feeling if this were a multiple choice problem, it wouldn't have a 1 there. Log base 2 of x. Now we move to the bottom. The 5 is on the bottom, so we say minus. Now the 5 doesn't have an exponent on it, so it's just log base 2 of 5, then a minus 2 log base 2 of y, and I'm about out. I'll just say right here, minus 7 log base 2 of c. What we're doing is we're going through using the properties of logarithms, the product rule, the power rule, the quotient rule, in the order quotient rule, then power rule, then distribute the minus, and find, no, quotient rule, product rule, distribute the minus, then power rule. So having seen that, if y'all see the pattern, the next one shouldn't be very hard. Number 7. Oh, let me move it up. Does it need focusing? Should I focus? Let's see. Can I get any further? Nah, it's about the same. Okay, so here's number 7. Log base b of x y to the 5th over z to the 4th. Sometimes you don't say, oh, I can do that without, just by looking at the answers. And yeah, hopefully that's true. Let's see. But I'm going to write out, because I feel like I've got to do something. X, y to the 5th over z to the 4th. Well, we separate at multiplication and division. So there's going to be 1, 2, 3 logarithms. How many minus signs? Just 1. Okay, so we start off. There's not an exponent on that x, so it'll be log base b of x plus or minus plus 5 log base b of y, and then a minus 4 log base b of z. Oh, and you got to look really close when you're just glancing at these. All the answers look the same. Is it b? B? Any questions there? And algebra in particular, you always do it one way, then you do it in reverse, which is what we're about to do. On problem 6 and 7, we were expanding logarithms. On 8 and 9, you're condensing logarithms. So, well, how would we go about this? Let's see. Write this expression as the log of a single number or expression. Okay, key phrase is single. Okay, you're writing it with just one logarithm. And so this just says log, there's not a base stated, so that's not the log key on your calculator, log base 10. But okay, so we don't have a base stated. first thing I do when I look at this, if I'm going backwards, I'm asking myself, okay, is there going to be a fraction bar? Yes, because of this minus right there. Now the stuff that has a plus in front of it goes on top. So it would be a w to the 5th and a z to the 6th. The number in front of the letter L is the exponent. Okay. Now here's the tricky thing. Don't put a plus in between those. You don't separate logarithms at addition or subtraction. If there'd been a plus right here, we couldn't have separated the y squared and the x. You separate at multiplication and division. So if you're going to put a symbol there, you can put a dot for times, but no plus. And then in the bottom, just the x minus 5. Notice how the x minus 5 wasn't separated. You can't separate at addition or subtraction. You separate at multiplication or division. So the x minus 5 stayed together. And this one's very, very tricky. The answer is A, if I'm looking at this correctly. What do you think the common wrong answer is? C. Okay, there'd been a plus there. It couldn't be separated. Okay, so it would have to be. Okay, if you tried to expand this, you would only get two logarithms. Log of the top minus log of the bottom. All of this would have to stay together. So all of that to say it's not C.
Not B.
And it's sure not B either. The x minus 5's on the bottom, not on the top. And it's not D. They have the exponents wrong. They put the 6 on the W when it should have been a 5. Okay. Now what about problem number 9? Let's see, can I see it? Those are those natural logarithms. They look like an IN, but it's really an LN. And so, let me go ahead and write it. ln 2x plus 2 plus ln x plus 8. To condense this down to just one logarithm, one ln, I ask myself, okay, is there going to be a fraction bar here? No, okay, because of that plus. If this plus that I just circled was a minus, then there'd be a fraction bar. So it's just going to be 2x plus 2 and x plus 8 with no symbol in between it. If you feel the need to put a symbol, don't put a plus, put a times. And that answer's not one of the listed answers. What am I going to have to do with this 2x plus 2 and x plus 8 to get one of those answers up there? Foil it out. If I FOIL out 2x plus 2 times x plus 8, what would I have? I'd have 2x squared. So this course started very much like just a traditional algebra course. Plus, oh wait, what did I do? That's not an 8x, it should be a 16x, right? First, outer, plus another 2x, plus 16. So 2x squared plus, is that going to be a plus 18x plus 16? Let's see, is it D? If you look at these answer choices, it would have been B if this circled plus right here had been a minus. Then you would have had the 2x over x plus 8. Any questions there? Let's take a break for a moment.